Okay, we're back for part 4 of our turbocharger little video series here. One thing we need to hit is the AR number on a turbo. So when you're changing out a turbo, you need to make sure the turbo you're putting on has the same AR number stamped on the housing. So AR is a ratio between the area of the inlet into the turbine and the radius of the housing. So that's got to be properly matched to the application so that it'll all work right. So that's what AR rating is, and it's AR ratio, and it is stamped on the housing. Okay, so the center housing and bearings we haven't talked about. The center section of the turbo is called the center housing and the bearings. It's a little bit hard to see on this one, but our oil comes in here and comes out and goes to these two bearings. The bearings have holes in them, and they're like full floating bearings, so they can spin in the housing and on the shaft as well. You gotta remember, this can go up to 180,000 RPM, so the bearings have to be in really good shape. This is the older technology here on this turbo, which is called a plain sleeve type. We used these for a long time. It's just two bronze alloy sleeve type bearings on each end. So with this setup, you have to have a thrust bearing out here on the end of this to control the in play on the turbo shaft. So one of the problems with these was you would have coking. So coking is oil that kind of gets burnt and hardens. So people will like have a turbo really hot driving down the road and pull in and just shut it off like they would their automotive vehicle. That's very hard on the turbo because the turbo needs to have oil circulated through it and cool down a little before you shut it off. So you need to let the turbo idle for a minute or so and then shut the engine off. Very few people do that, so that oil that gets stuck setting inside here would kind of burn and not really crystallize, but sludge. It's kind of a hard carbon substance that it turns into, so it would start limiting the actual movement of the turbo, and that's what you do when you're checking the in play, is checking for that. Also, to make the turbo spool up faster and spin quicker, they've gone to some newer technology to avoid like turbo lag. And the newer technology is angular ball bearing type. Now, on the angular ball bearing type, you don't have the thrust washers anymore because even though they're ball bearings, it's a little bit closer to like a wheel bearing would be, being angled. When they tighten down, they control the in play there, and you don't have to have the thrust washer anymore. And you have a bearing instead of a sleeve type bushing, so there's less resistance for the turbo to spin. So that's the newer technology that we've gone to. They avoid that coking because you don't have the thrust out on the ends. So on the very end, outside the bushings there's two piston ring type seals that seal off the oil from the center to keep it from going out the exhaust or into the air intake. Broken or worn seals allow large amounts of oil to escape, obviously, and it's kind of problematic. This leads to what's the common term is turbo slobber. So turbo slobber refers to oil being passed into the exhaust system from the turbo caused by excessive idle time. So you want to let it idle a little, but we have also people that say you never shut a diesel off, and they leave them idling for long periods of time, especially like in the oil field. So the problem with excessive idling is there's no boost pressure at idle. Turbo's not going very fast. There's not a whole lot of movement of air into the engine and exhaust out. So anyway, what helps these seals seal off is having more pressure on the housing side than in the center bearing side. So excessive idling allows that oil pressure to kind of push past the seals because there's less pressure on the turbine and compressor side. So that allows oil to kind of be pushed out. So excessive idling is bad. Other possible causes include high crankcase pressures. If you got engine ring problems or something giving you high crankcase pressure, then oil can be pushed out of the turbo because it's hard for the oil to return to a pressurized crankcase. So it kind of backs up into the turbo and allows it to be more likely to leak. Restricted air filter. This thing is being forced to pump air. So if you have a restricted air filter, it's going to pull out of the center housing and pull some oil into the air intake side. So a restricted air filter can cause that, and then obviously damage seals. As far as diagnosing that, where the oil's coming from, some people will tell you you can take the exhaust manifold off and run the engine and see if oil's coming out. So in other words, the oil's getting there before it gets to the turbo. Probably a better way is to put some dye in the oil and run it, and then take it apart and hit it with a black light, and you'll be able to see the oil coming past the seals because it will glow kind of like you do with air conditioning leaks. Okay, the last little part here. This center housing assembly and the turbine wheels are balanced with special equipment. So you won't be rebuilding turbos or taking a part off of one turbo and putting it on another. That would be bad. There's special equipment involved. So basically you send it to a turbo shop that has all that stuff, or just buy a replacement turbo. So you're not going to be like really rebuilding them. And by what I mean, as far as balancing these, they've got the equipment to spin them and balance them out, and they remove metal to balance it. So over here on this compressor wheel, I'll get it right up here. You'll see on this video, but they have ground metal away on the end of this wheel to help balance that. Okay, it's a little more dramatic over here on this turbo. On the turbine side, if you look right here, they ground a lot of metal away, including the end of the shaft bolt here that holds it together. But there's a big flat area ground out here, part of the wheel and part of the end of the shaft. That's how they balance them, so they have to grind it and remove metal to balance that out. Should pretty much wrap up our little turbo series here.